Hey guys, in this video I will show you how to create this table generator, and here's what you can do with it. It's just a basic animation I did, keyframe animation, just to show what parameters could be tweaked, not parameters, and what could be done with this tool. And here's a whole node graph. This part is not related to this breakdown because this is basically an HDA. I have created a keyframe. I add some keyframe animation to it, and this is basically what you saw in the beginning of the video. And here's pretty much the whole node graph. It's pretty compact, I would say. So this part is this is a controller which has all of the parameters that could be tweaked from one node. It's a null node, just in case. And here is a part where I create legs and the top parts of the table, and here's bottom plank or whatever it's called. And here I'm doing a post process, and here I'm creating auto UVs and exporting geometry, and that's pretty much it. So let me show you how I did it. So everything starts with a grid. It's a grid with 2x2 columns, some line, and this is a dependency link which you can enable under the view and show selected nodes. And you can switch for all of the nodes, but it just becomes a mess to navigate through the graph pretty easily. Usually I prefer for selected nodes only. Here you can clearly see where I have add a reference, like copy parameter, and paste relative reference somewhere, like here. And here I can clearly see where some of the parameters is used. Like I said, it starts with a grid, and then I'm doing the polybevel, and here I enabled the stop loop simultaneously. This is just to stop polybevel when it hits other geometry, so you can see it just stops here, and no matter what value I have here, it just won't go any further. But if I switch to this option, it will do crazy stuff. And then I'm doing a fuse. This is just to fuse or merge overlapping points, as you can see, like in the middle especially. And then I'm using a switch node, as this is just for the controller. But basically what it does is it switches between round and square shape table. Let me show you actually. Like so. So I copy parameter of this drop-down menu, copy parameter, and paste relative reference. Oops, like this. So basically, the value of hard edges will be 0, and the value of the round edges will be 1. So it's basically whenever the value is 0 or 1, it will switch to different type of to the different shape of the table. And you can add under the ordered menu, you can add your own labels. So you need to go onto the menu items, and the token will be a digit number, so 0 and 1, 2, 3, 4, 5, and so on. And if you need to add another, you can do it like so. So after that I'm extruding the top part downwards. I'm also extruding a front group and side group. Then I'm doing an insert with another poly extrude, and I'm also referencing a front group from the first poly extrude, this from group, copy parameter, and paste relative reference. This is just to make sure whatever, if I want to change this group name, like something like this, it will still work because I have pasted the relative reference. I'm doing another insert, and I'm also exporting from the group for this insert. Let me actually show you as well what it does. And this is what the group would look like. And then I'm using a fuse node. This is to, like, I can't actually recreate this issue I had, but in general it just fixes a reversed faces issue. So yeah. And then for the inner plank, like extruded, for this plank, for this portion, sorry for my amazing drawings. So for this plank, right here, I'm converting these points, like these points. I'm converting them to edges using a group promote node. And I'm specifying a group name. I'm sorry, not points, faces. I'm converting faces to edges. Yeah. And then I'm extruding this single edge, like edge loop. And then I'm also exporting the front and side groups for this polyextrude node. And then I'm using another polyextrude just to add thickness to this edge, to this extruded edge. And here under the second polyextrude, I have used a side group from this first polyextrude. And then I'm just merging everything together, fusing points again to fix overlap issue, and then reversing the whole thing. And this clean swap, I have enabled manifold on the topology. This is also to fix some issues which I had. I can't actually remember what is the issue and how it would look like, and how it looks like, but yeah. And then I'm adding another polybevel. And then I'm adding a polybevel. I have excluded some of the edges, just in case. And then I also changed the stop loop to this value instead of individually. And the divisions is being controlled by the controller. It's basically this value. And everything else is pretty much by default. And then I'm doing another polybevel, but for the inner plank. This is how I call it. I'm not sure how it's properly called. And I'm using a front group from the inner plank depth polyextrude. And then I'm creating a name swap. This is just to add a USD primitive path which I haven't used, but it's here just in case. I want to explain it why it's needed, because it will be out of the topic. So to create legs, you need to have a line. I have 40 points, and then I'm using a sweep node, and also a circle as a cross-section shape. This is basically to determine the shape of the after the sweep was done. And I can also change some of the values here. And under the sweep, I have also enabled a single polygon under the end caps. And I'm also using the scale ramp here. I just set it by default to steps. And I have disabled roll and twist. And I also enabled a reverse cross section. This is basically to reverse faces. And everything else is by default. And what with sweep node, this is actually really good because I can control the look of the legs. With a little bit of tricking. It's just like for demonstration purpose only. And here's how it would look like actually. And the reason it looks like not as before is because I'm also using here a poly reduce SOP, and just to reduce polygons. So it would look like something like this. The poly reduce SOP is actually just to remove some of the edge loops, which are not really necessary. So for example, 100 means to keep all of the points, to keep all of the edges, and if I start decreasing this number, some of the edges will be deleted. And this is just like kind of a procedural way to handle this. So yeah. So, and this is pretty much why the poly reduce here is used. And I also enabled the preserve quads option here. And after that, and then I'm copying legs to the points. And now what about this part? So this part is used for the circle shape only. And the reason is because when the circle shape has been selected, there are a lot of points here. And so meaning the leg would be copied onto every single point here. And this is not what we wanted. And to kind of fix this issue, what I have done is I copied all of these nodes here, these two poly extrude nodes, and not just copied it, I have created a reference copy. So basically everything is being referenced to this node here. But as you can see here, this is a circle shape, but reference copy has a square shape. And this is because I have like added another stream, a node stream, or whatever it's called, like a separate section of the node graph. And then I'm promoting or converting edges to points, like these edges. I'm converting it to points. And the reason I need to convert this to points because I need to copy geometry to points, which is done like here, as you can see here. So whenever I change the extrusion, legs will be placed onto a square shape insert anyways, instead of the rounded edge. And because otherwise it will look like this. If I copy every leg object, if I copy leg object onto the every point which rounded edge has, and that's pretty much why I have this pretty much identical nodes. So yeah, and then I'm just also using a USD primitive path, and after that I'm merging everything together, and the bottom plane looks like a bit of thick right now, and we can actually control it like here, actually from the controller. You can control the height of the plank. By the way, I haven't enabled the like maximum and minimum distance based on the bounding box or whatever, so it can go beyond the table right now. and the plank thickness, and here we go. So the bottom plank is done pretty easily. I'm referencing an inner plank from group. And so I'm blasting this geometry, and then I'm using an end node. And under the end node, under the polygons by group, I have enabled the closed option here. So basically, it will create a single polygon here. And then I'm using a convert line swap just to convert a polygon to line. And here where an interesting part comes in, and possibly a confusing part. Let me actually preview it. So here I'm using my mesh size, and I'm also importing via object merge legs. This mesh. And the reason I'm importing it is because I want to have an object which I can reference and transform this bottom plank based on some other geometry. And some other geometry is legs in this case. And there's also a great video by Paul that you can check out. And so here I'm using this option, and target group is set to bounds, and bounds is bound swap. And here I enabled the bounds group. I will come like a bit later. I will come back to this node just in a minute. So this controls the height of the bottom plank. And I'm also enabled the scale to fit, because by default it will be like so, because I'm, as you remember, I'm blasting this single polygon, converting it to line, and then transferring it. And because it out of the bounding box, I'm scaling this object to fit the entire bounding box to be like so. And then I'm using a sweep node as well. With these parameters, I have changed it to square tube. Then I'm using a polypebble. Then I'm transforming it. This transformation is basically a height or thickness. I'm not really sure. I think it's the height, because the height is the plank. So yeah, and also exporting a name attribute. And this switch swap is basically to control, enable, disable a bottom plank. And regarding this bottom plank, here I also have a bounding box object, and here I have an expression. So whenever it basically it's checking if it checks if the shape of the table is round or hard edges, and if it a hard edge, and if the table contains a hard edge option, this means equal to 1. And if you remember, as the hard edges option is equal to 1 in the attribute parameters interface. And if it's true, the bounding box lower padding will be set to minus 0.02. Otherwise, if the round shape, it will be set to 0. So in our case, in this case, because it's set to round edges, it's set to 0, but if I switch to hard edges, it will be set to 0, 0, 2. And here's other settings. Basically, I'm copying this parameter and pasting it here. Except here I also added a little bit of padding here manually. And this is needed basically to control where the bottom planet will be placed. Because if not using bounds, it won't be fit properly. And after that, as I said, I'm fusing all the points. If there is a need to create a single leg shape. Can be also done like so by changing the table size. And then I'm using the match size to place a table on the ground plane by using a justify y to mean, which is set to mean. Then I'm using a clean to clean off the groups and attributes, and to clean off the groups except name attribute. Then I'm scaling it up, and this geometry is just to reference. You can scale whatever you want here. Basically, this will be better. And then I'm using computing UVs, doing a UV layout. Additionally, if you want to use this table generator inside Unity or Unreal, you have to convert this graph into the subnetwork, which is this one. I won't be doing it because this will be out of the topic of this breakdown. But in case you're wondering, here's how it would look. So here I have a simple third-person template, and here's the table generator I have imported from my OTL's default folder, which is located on the C drive, documents, and then Houdini folder. I will write a link in the description about how to install Houdini Engine and how to import HDAs inside Unreal, because this breakdown will be too long. Basically here I have all of the options from the controller. I can enable UVs here, I can change the table size here, and it cooks. Yep. So I can change the table size once again. I can basically change any parameter which I have in the controller. I can also change the height of the table, flex placement, round or hard edges, and it also has a collision. And I will also leave a link in the description on how to add a collider using inside Houdini, just with a simple group method. As you can see, here is a collider. So that's pretty much it. Hope you found it useful. Hope it wasn't too confusing. And if it was confusing, please consider